Good evening. This is going to be the introduction for my new Udemy class. Still getting just the base of it, the framework laid out. So this is going to be the intro for this class. I'm going to put it on here, and this is some of the things that you can expect to see in the near future. This is, like I said, just the baseline for what I'm working on. And I'll spend the next couple weeks probably fleshing this class out, making recordings and so forth, and many other things. I will do a lot more production, make a higher quality production than my normal videos, of course, because that'd be for paying students and so on. But on the YouTube channel, you'll probably get a lot of my raw cuts and much of the same information. This class is going to be called Creating a Lab. The byline on this is creating a testing computer lab for, that's redundancy, creating a testing computer lab for testing. So I need to create a computer lab for testing, training, and many other reasons. First and foremost, what is a lab? In this context, a lab is computers that can be virtualized or on real hardware and created in a closed environment. What I mean by a closed environment is that it can connect to the internet, but it's not serving any kind of production information. A lot of times these aren't really connected directly to the internet because they may be, the configuration management may be very weak on these computers, just because they go through so many cycles of being tested, being blown away, and recreated, and so forth. So a lot of times you don't have the lab directly on the internet. That can change though, especially if you need it to be on the internet. This closed lab environment can consist of one computer or an entire network. And what I mean by that is your lab may be nothing more than another virtual machine, say it's a Linux or a Windows or maybe even a Mac OS virtual machine. And you're learning the operating system on that. Or I've worked in computer labs that are as big as a small data center. So they may have like 30, 40 racks of computers, servers, and network devices and so forth. And this way, when we try to introduce new technology into the enterprise environment, we can introduce it there and spend 3 to 6 months testing it to make sure that we're not breaking anything. Because we may have hundreds, if not more, network devices and applications and so forth on that network, and one little change on there can have an impact that would be hard to determine. All right. This combination of virtual computers and hardware, or any combination of virtual hardware and real hardware, can be used. Right. So what I mean by that is that you can get an old computer, create virtual machines on that. So you have like your old gaming computer. You spin up like 4 virtual machines on there, but then you can also take live hardware, say like a firewall device or a router or a switch, plug it in, and then configure it to where the virtual computers are communicating across the hardware itself, like the live hardware, like say going through a Cisco switch and being VLANed off, hitting a router, and coming back down to other virtual computers. So it can be any combination of all of these things. And basically, there is no such standard for a lab. The lab is going to be created based on the requirements. Sometimes a business wants to stand up a lab just to test their applications on, and if developers are constantly adding or creating or changing their web applications, that lab will allow them to do that in a safe environment without ruining the production environment. Examples of this is a service can be created to develop a new web application, like I said, where the app, the database, and other services are not on the same platform. And what I mean by that is usually in a commercial environment, your web application may be in the DMZ, the demilitarized zone of your network, but the database and the middleware agents are more in the center of the more protected part of your network. That way you can deploy your web application So it's usable by internal and external customers. You have a smaller rule set going to it, but you also have very specific ports and protocols that talk to that web app only, right? So it's in a less protected area of the network, whereas your database would be in a very much more protected environment. So you can create this web app like you would deploy it in real life or very close to it. Security testing is another one, right? So whenever like Patch Tuesday comes out, every second Tuesday of the month, new patches come out, and on the enterprise level, we have to deploy patches. Well, you need to test these patches out before putting them straight to production because they may have unknown consequences. Even the best intended company sometimes puts out a patch that can create a lot of harm on a network or a series of computers. So you want to test these out for a set amount of time to make sure that the new patches aren't going to break anything. Also, if you're doing any configuration changes, such as like applying new group policy objects, or you're applying whatever the configuration change is. Maybe you're locking down the computers a little bit more stringently, so the computers or the servers can only be used in very specific ways. You want to change those or test those configuration changes in a lab before you push it to production. And on information security, this is where I've got most of my experience in creating labs, because in order to be a decent network defender or penetration tester, you have to get a lot of practice. It is not legal to take these techniques across the internet. So you can get a lot of trouble and spend real time in jail for crossing the internet. So that means even you've run the potential of even getting in trouble with the law if you leave your network and come back into your network. So say you're executing an attack across a VPN, but attacking your server inside your network. So you're leaving outside your VPN tunnel and you're coming back in from the internet to your own computer. You can potentially still get in trouble for that. So the live environment allows you to put out computers that will never leave your house. Right? They'll never be on the internet, and then you can practice your penetration testing all day long, and at the same time you can also practice defending against that. I think the why they created a lab I've covered already in some of this there, but some of the higher level areas I look at is like first and foremost you're a student. You're a student either changing careers, you're a student in the university or high school, or you're somebody that's just updating and upgrading your certifications and getting new skills. I consider all of these in the student category. And for students like in the university or high school, the labs to cover all of the students are usually just going to be cost prohibitive. You can stand up a lab, but it's very hard to have all the students be able to interact with that lab at any given time. So then you're kind of slicing off lab time per student, and some students pick up these techniques and things so very easily. Others do not. So it's very hard to carve out a specific set of time, like 2 hours a week per student, when it may not be sufficient for some students. Also, on this, you do want students the ability to make mistakes. Making mistakes is the best way to learn how you made the mistakes and reinforce how not to do it next time. Some of these mistakes may completely destroy a computer. You'll have to rebuild that computer. Now, if you're building a virtualized environment, it makes it very easy as well. You can just reset to a snapshot or whatnot, or just drag in an ISO that you already created and have a new computer stood up and reconfigured in a matter of like 10 minutes or so. In this way, the students can make these mistakes and not feel like they're causing a lot of damage. They just have to reset and start again. And like it says here, other hardware parts can be cost prohibitive. Router switches and firewalls, even though you can go on eBay and find decent equipment for relatively cheap, that's relatively cheap based on your income. It could be prohibitively expensive for others. And having the ability to create labs using free or very, very, very inexpensive hardware it really benefits the person learning. And like I also mentioned on penetration testing, uh, first and foremost, you never penetrate another computer system without explicit authorization of that computer system owner, and that's going to be a very legal document, and so forth. So you do this as a professional. You would not do this for practice, right? This is called hacking, and hacking will get you into trouble. And you also do this because penetration testing can be destructive. You may accidentally send out an attack to a computer that breaks the operating system, does something to the kernel so the computer doesn't operate, or you may accidentally lock the computer up to where you can't even log into it anymore, and you can't hack your way into it, right? And one of the benefits on penetration testing, if you have your own lab, is that you can see the attack because you're executing an attack, but you can also see from the defender's perspective. So you can capture all those log files and you can definitely see the attack happening in real time. This will be beneficial for you to understand at a very deep level how an attack is executed and how it works. And finally, examples of a lab. First and foremost, a person studied for a certification I'm putting here, such as the CCNA or CCNP, and purchases used switches and a router on eBay to practice. This is a lab. You're buying real equipment, you're setting it up, and you're going to be configuring this hardware to communicate with each other in multiple different configurations. That way, when you go to take a test, you have the actual keyboard experience and not just some book knowledge, right? You're doing a lot of reinforcement training. Another reason I've seen a couple different times is somebody's creating a new web app that they want to create and then hopefully put on the market and start their own business with, right? So they'll buy a couple of old computers, and these couple of old computers can either replicate the servers themselves, so they can have one server as the web app, another server hosting the database and other components, or they can take those same servers and turn them into a virtualized environment. And in that virtualized environment, then you can also create that network a little bit more robustly and still create the same components, so you can run the application. You can flesh it out, you can get it ready for production, and you can get it out on the market. And finally, again, the student learning for like computer networking as an example. The student will need access to many operating systems, network devices such as routers, switches, firewalls, DNS servers, and so forth. And they create this network in this virtual space, and it's on their own computer. So for like the college student or the person that's transitioning careers, you might only have that one computer at home. And you can definitely stand up a lab on your dedicated hardware, on your laptop, and then you can get this much needed practice. This also allows you a way to make these mistakes again, to reset and to start again. Or you can try different things, and if you, for whatever reason, cause harm to that virtual machine, all you have to do is start it up again. And like I said, mistakes are a great way for learning, and that's the greatest reason to have a lab. So, with this, we'll go on to the next part. But for this will conclude this portion of the demonstration.